You're welcome to lecture number 1-2. This is a pre-calculus mathematics 164 at NJCU. In these lectures, we are going to study about relations and functions. Again, what is a function and also what is a relation. So first we start with functions. Here we're going to determine whether a relation is a function. Also to state domains and ranges of certain functions. So our main goal is to learn what is a domain and what is a range of a function. Also using the function notation and to perform operations with functions, and also how to find the composite of two functions. So first, what is a relation? Here we said the relation is defined by a set of ordered pairs of real numbers. Normally, these numbers will be to the x and y coordinates. So these ordered pairs may be determined from the table, a graph, an equation, or an inequality. For example, I may have a table of x and y values. X can be the independent values and y will be the dependent values. Or I can use an equation such as the one we have here, y equal to 4x minus 3. And when x is 0, what is the value of y, which is negative 3? When x is 1, what is the value of y? That will give us positive 1. So this will be again a relation, the x and y value, 0, negative 3, 1, and also 1. So we can again get our other pairs, which is x and y values, either from an equation as we are seeing it here, or from a table, or also from a graph. And always we're going to write the other pairs in the relation in the form of x and y. So always our first value will be the x value, second value will be the y value. So that's why we say the x value is independent, because it depends on, it determines the y value, and y is dependent. Y is dependent because x, which is independent, determines the y outcome. So an equation frequently expresses how the second component, which is the output, in this case the y or dependent, is obtained from the first component, which is the input, which is the x value or independent. So definition of a function, we said a function is a relation between two sets such that to each element of the domain, which is the input, domain will be the x values, there's a corresponding exactly one element of the range, the output. Here, what we are trying to say is that if the input is 2 or 10, one value, the output also should be one value. Now, if the input is one value and the output can be more than one value, then that's not a function. So it's a function, is a relation between two sets such that each element of the domain, which is our input or the x value, there corresponded exactly one element of the range. And we will see some examples. A function may be defined by the set of other pairs. It can come from a table, a graph, or an equation also. But what makes the relation a function is that always the input should give us exactly only one output. And if we have the same input, we should get the same output. Those are the two conditions. So now a question said, does y squared equal to 2x express y as a function of x? The answer is no. Why? Because if x is 1, I will get y squared equal to 2. So y will be the square root of 2. Square root of 2 can be a positive or negative two values. So let's use 2, which is more simple. So if s is equal to 2, y squared will give me 2 times 2, which is 4. Then to find y to be square root of 4, square root of 4 will give me positive or negative 2. And so this is not a function because we said earlier, our input should give us exactly one output, not 2 or more outputs. So let's see the solution here. We say no, because some values of x are associated with more than one value of y. In fact, there are two y values for each x greater than 0. Now, for example, if x is equal to 8, then y is either 4 or -4, because 2 times 8 will give me 16. Y squared equal to 16. So the square root of 16, which is equal to y, will give me either +4 or -4. So that's why, again, it's not a function. So equation y is equal to 2x express a relation between x and y, but y is not a function of x. There's a relation there, but it's not a function of x. Again, the reason why, because one input can generate two outputs. Like s equal to 8, we get +4 or -4, which is two outputs. Sorry. So the idea of a graph of a function, maybe we know this already. This is our Cartesian. So here we have a 2-dimension x and y values. So we have quadrant 1, 2, 3, and 4. In quadrant 1, both y and x value is positive. In quadrant 2, we can see that x values are negative, but y is still positive. In quadrant 3, y and x, both of them are negative. So we can see 6, -4, -4. Here we get -4 and +1 because y will always be positive. And in quadrant 1, we get 5 and 2. The goal is that always in quadrant 1, y and x are positive. But in quadrant 4, we can see that x is positive, but y is negative. So example of a D point will give me 1, which is positive x, but y is always negative down, so -5. So a graph of an equation normally defines a function or a relation, and the graph is a picture that results when we plot the points whose coordinates are x and y values satisfy the equation. So to sketch a graph, we can plot enough points so that the shape of the graph and draw a smooth curve through the points. Normally we say that to plot a graph, first it's good to have a table. As I'm plotting a graph, y equal to x² + 1. Also, okay, my graph should be between, let's say, -2 to +2. So I'll say, okay, when s is -2, -1, 0, +1, and +2. Then based on the equation, I'll find the value of y, substitute each x value. Now when we have the table, every point have only two coordinates, s and y value. So we plot the points. So there's another way we can test if a function is a function or if a relation is a function. We call this a vertical line test. When you are doing vertical line test, you draw a vertical line through the graph. If any part of the graph, the vertical line can cross it at least a minimum of twice or 3, then it's not a function. It's only a function if the vertical line crosses all the graph portion by only one time. So we say if no vertical line exists that intersect the graph at more than one point, then the graph is that of a function. So again, if no vertical line exists that intersect, so here we're trying to say that when we have a vertical line that does not intersect more than once, then we have a function. If it intersects more than once, then we don't have a function. So this is an example given to us. We plot a function with the equation y equal to 4x². We start with the x value from -1 to 2. So when s is -1, 4 will give me +1 because -1² is 1, 1 times 4 is 4. When s is -half, -half will go here, so it will give me +1, 4. So the answer will be 1. When x is 0, y is of course is 0. Any value times 0 is 0. Then we same thing, we go with half, we get 1, 1 we get 4. 2 square is 4, 4 times 4 is 16. So with this table now, I can just plot each point. The point will start with -1 and 4, then -1/2 and 1, then 0, 0, so to be on the originate, then 1/2 and 1, 1 and 4, 2 and 16. So from here, we plot our graph. Again, we plot in a graph of y equal to 4x squared. So we make up our value of x from -4 to +4. Then we substitute each x value to get the y. Then we plot. Our goal, we want to test if it's a function or not. We use the vertical line. So I draw the vertical line through the graph. I can see that it intersects twice. So if it intersects twice, that means this is not a function. The next section we're going to learn is function notation. And normally we use y equal to f at x. Our function notation will be f at x. So here we say f at x represent the values of a function, that is output or y values are those s values. So example here is that we have a number of personal income tax returns filed electronically, T in millions, was able to model by the following function, T at x equal to 6.35x plus 4.65. And these values are in millions, where x is the number of years after 1995. So first we want to find T at 20. So T at 20, we know our function is T at x, which means we are going to look for the value of the equation when x equal to 20, T at 20. So we substitute 20 for x, and our answer will be 131.65. And the second question also said, write a sentences that explain the meaning of the result in part A. So the statement T at 20 equal to 131.65 means that in 1995, remember the year 1995 plus 20, which is 2015, approximately our answer was 131.65 million personal income tax returns were filed electronically. And this question is given is that this model was tell us the number of households that file the income tax annually. But S doesn't represent the number of households, but rather it represents the time. So we start from 1995. If I say find T at 20, it means I'm looking for 2015, a year, because 1995 to 2015 will give me 20. So we plug in the value, we get 131.65. Then we explain what our answer means. Again, here the answer is telling us that by the year 2015, because 20 years we start from 1995, approximately 131.65 million personal income tax returns were filed. Now, next we go to the domains and range. Domain will be the x values of a function. Ranges will be the y values of a function. So we will limit our discussion in this test to real functions, which are functions whose domains and ranges contain only real numbers. So let's see example here. Here we are given y equal to 4x squared. B, we say y equal to square root of 4 minus x. C, y equal to 1 plus 1 over s minus 2. So we want to find the domain of each of the following functions. Then later we find the range. So here we have y equal to 4x squared. The domain of this function will be any real number, because any number I use for x, I will always get y. But in B, the domain will be any value that will not make square root value here negative, because square root of negative value does not exist. So here we can say that the domain should be any value that is less than or equal to 4. Or we can say that S should not be greater than 4. The second, we don't want to have a division by 0. So here we say the domain can be any value except S not equal to 2. Because if S equal to 2, again, this function does not exist, or it's not a function equation. And here also, if it's negative value, it means what? The function is not an equation. So we say there are no restriction on the numbers. Substitute for x and a, y equal to 4x squared. Any value of x, we will get the value for y. So any real numbers is the answer. But in B, we said we don't want a square root of negative value. So S shouldn't be greater than 4. It should be less than or equal to 4. So we know that the restriction that 4 minus S cannot be negative, that's it. Thus, the domain consists of only numbers that is less than or equal to 4. So those will be the domain. A, the domain will be any real numbers. B, the domain should be any value that is less than or equal to 4. Then in the C, we should be equal to 2. So this function is undefined when S equal to 2, because 1 over 0 is undefined. So here the domain will be any value except 2. So operations with functions, there are so many operations we can do with functions. For example, the concept is same as polynomial. We did the polynomial already. In polynomial, we can do addition, subtraction, multiplication, division for polynomial. The same thing with operation with function. We can do addition, subtraction, multiplication, division. So if I have two functions that I'm adding, I'll just add them together. If I have two functions that I'm finding the difference of it, I'll just find the difference of it. If two functions are multiplied, we multiply them. If they are dividing, we divide them. Now we have what we call the composite functions. In composite function, the word composite means something that can be break down more. So a composite function means a function inside another function. So for example, if I have a function f and g, they are functions, then the composite function g of f means that f is inside g. So here, if I say g composite f at x, the answer will be g because g is outside and f is inside g. So it will be g into f at x. Or if we have f composite g, same thing to be f at g at x. Now let's see an example. If f at x is 2x cubed plus 1, and g at x is equal to x squared, we should find the following, the composite g of f at x or f of g at x. So g is what? S squared. So I'll bring the s squared out. Then anywhere I see s squared or anywhere I see x, I'm going to substitute with f at x equation. So we'll see what we get here. See, we get g 2x cubed plus 1. Because it will be g at x. But x, for the value of f at x, this is g composite f. So f at x is inside g at x. And f at x is 2x cubed plus 1. So we have g 2x cubed plus 1. The same thing apply here. We have f at g. So f is what? 2x cubed plus 1. And f composite g. And here we have g is what? S squared. So this means we are going to have 2s squared. The s squared is the x because we substitute s squared to the power 3 plus 1. And the same thing we also did here. So here we have g 2s cubed plus 1. And we know g is what? S squared. So we square everything here. So that gives us 2x cubed plus 1 all square. Why? Because g at s is equal to s squared. Here we open the parentheses, both sides, we get the final solution, which will be 4x to the power 6 plus 4s cubed plus 1. And here we get 2s to the power 6 plus 1. So again, thank you very much for this video. Again, in this video, we went through what is a function and also what is a composite function relation, how to test a function using the vertical line. As we said earlier, in a vertical line means if we draw a line through the function vertically, if it touches the function more than once, at least twice, then it's not a function. We also saw the composite function, which is a function inside another function. Again, I will solve homework assignment practicals in my next video in this topic. So again, wish everybody the best. Thank you. Like this, comment, or like the video, or please you can also subscribe. Thank you.